Okay, so in this video, we're going to be talking about angles of depression. An angle of depression is when something or someone is looking down to an object. We have an angle of depression that is formed, meaning for this lifeguard, his normal line of sight is going to be this horizontal to look down on a swimmer. He has a line of sight that would go down at a diagonal, and it has an angle of depression. If the swimmer actually looked up, he would have an angle of elevation. The angle of depression and the angle of elevation for both of these two people would be the exact same, because the lifeguard's horizontal line of sight and the swimmer's horizontal line of sight are parallel lines. So these two angles are alternate interior angles. And if you remember, alternate interior angles are congruent. So the lifeguard's angle of depression and the swimmer's angle of elevation are actually two congruent angles. The line of sight between both of them is the same line of sight. So again, an angle of depression is formed when looking down to an object. The angle of depression is formed by an observer's line of sight and a horizontal line. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. So we're going to talk about some examples. Again, we're going to have to draw these examples so that we can see what's going on. So this problem says a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far is the swimmer from the lifeguard? So, and this is drawn out for us actually in this picture right here. So let's look at this picture. So we're going to take this, and I'm just going to move it over here so that we can see it just a little bit bigger. All right. So this says that the lifeguard station is 8 feet above the ground. So this is going to be my 8 feet here. It says the angle of depression is 18 degrees. And I want to know how far the swimmer is from the lifeguard stand. So I'm looking for this. Now, there's a couple things I want you to notice. Notice that if I drop another line right here, I have a very pretty rectangle going on. And if I remember things about a rectangle, I remember that opposite sides are congruent and that all my angles are 90 degrees. Okay, but this angle right here, my angle of depression, that's the one I want to focus on. So based on this angle, and now I'm going to focus on this right triangle. Based on this triangle and that angle, I'm going to label my triangle with opposite, adjacent, and hypotenuse because I'm still using my trig functions. I'm still using the sine, which is the sine of theta, which is opposite over hypotenuse, the cosine of theta, which is adjacent over hypotenuse, and the tangent of theta, which is opposite over adjacent. So I want to identify what's what in this triangle. So the opposite of 18 degrees is 8. The adjacent is x, and my line of sight is my hypotenuse. I'm not looking for my line of sight, I'm looking for my adjacent, and I'm being given my opposite. So which trig function am I going to use that uses opposite and adjacent? Well, that's going to be my tangent. So the tangent of 18 is equal to the opposite over the adjacent. When I have the variable in my denominator, it creates a two-step problem. To get the variable out of my denominator, I have to multiply by the denominator. To get anything out of a denominator, I always have to multiply by the denominator. So I have x times the tangent of 18 is equal to 8. Divide by the tangent of 18. What I do to one side, I do to the other. So I get x is equal to 24.6 feet. Remember when you do these to make sure you are in degree mode. If you are not in degree mode, you will get the incorrect answer. Okay, so this one says a helicopter spots a landing pad below. The angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet. What is the altitude of the helicopter? So we need to know a few things. First of all, we need to know that my helicopter is usually in the sky. Not going to draw a helicopter for you. I mean, you can draw your little rotator parts if you want to. So there's my helicopter in the sky. And it spots a landing pad. So my landing pad's somewhere over here. It says if my helicopter is looking straight across, then this is going to be its line of sight. The angle of depression means that it had to look down to see my landing pad. So this is a 73-degree angle. The horizontal distance to this landing pad is 1,200 feet. And I want to know what is the altitude. So how high up from the ground is my helicopter? Remember that I can finish off this rectangle like so. And opposite sides of a rectangle are congruent, so this is also x. Remember that these two angles are congruent. So this angle down here is also 73 degrees. And I can use either angle or either triangle to solve this problem. This base down here is also 1,200 feet because that was my horizontal distance. So there's a couple of different ways that I can set this up. I'm going to go ahead and use my top triangle simply because I think it's the prettier one. No, it doesn't really matter. I'm just going to use this triangle here so I can focus on the angle of depression. If you use the bottom triangle, it still works. Based on the 73 degrees, I'm going to set up my triangle with opposite, adjacent, and hypotenuse. So this x is my opposite, the hypotenuse is my line of sight, and the 1,200 is my adjacent. I want to use, let's see, I'm using the opposite and the adjacent, so that's my tangent. So the tangent of 73 degrees is equal to the opposite over the adjacent. In this case, my variable's in the numerator, so this is a one-step problem, so I'm going to multiply both sides by 1,200. So I get 1,200 times the tangent of 73 degrees, and that tells me that x is equal to 3,925 feet. So that means that my helicopter is 3,925 feet off the ground. Okay? Okay, so this problem tells me that a building is 480 feet tall and another building is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart are my two buildings? So, I have building A and building B. Building A is 480 feet tall. This is building A. Building B is taller at 654 feet tall. And the angle of depression from one to the other is 42 degrees. So this angle is a 42-degree angle. And I want to know how far apart are the two buildings. So I'm looking for the horizontal distance. I also need to know what this distance here is, but I can find that. So if one building is 654 feet tall and the other building is 480 feet tall, then doesn't that tell me that the difference, if I subtract 654 from 480, isn't the difference between these two 174? So I know that side. That's 174, and I'm looking for this side. So based on 42 degrees, my 42-degree angle, This side is my opposite. 174 is my opposite, and x is my adjacent. So again, I'm using the tangent. I seem to be using the tangent a lot here. That's not necessarily always going to be the case. So the tangent of 42 is equal to the opposite over my adjacent. Again, this has the variable in the denominator, so this is going to be a two-step problem. I'm going to multiply both sides by x because I need the variable out of the denominator. So I have x times the tangent of 42 degrees is equal to 174. Divide by the tangent of 42 degrees. And I get x is equal to 193.2 feet. So these two buildings are 193.2 feet apart. Okay, so the last example for this video says that Zach is standing at the top of a lookout tower and spots a water fountain below. The lookout tower is 75 feet tall and the angle of depression is 28 degrees. What is the horizontal distance between Zach and the water fountain? So Zach is at a lookout tower. And here's Zach at the lookout tower. It says the lookout tower is 75 feet tall. So Zach just looked out straight. This would be his horizontal line of his horizontal vision. But he looked down at an angle of depression of 28 degrees. And when he looked down, he saw a water fountain. That had water in it. We're going to say it had water in it. Okay? And he wants to know what the horizontal distance is from him to that water fountain. So remember, we can make a rectangle. This would also be 75 feet. This would also be x. And the angle of elevation would also be 28 degrees. And I can use any of the triangles I want, but I want to use the one using the angle of depression because that's what this video is about. Okay? So based on this triangle, based on 28 degrees, I'm going to label this triangle with opposite, adjacent, and hypotenuse. So 75 is my opposite. X is my adjacent. So again, I'm using the tangent. So the tangent of 28 is equal to opposite over the adjacent. Again, I have a variable in the denominator. To get the variable out of the denominator, I have to multiply both sides by x. So I have x times the tangent of 28 degrees is equal to 75. I'm going to divide both sides by the tangent of 28. And I get 75 divided by the tangent of 28 is x is equal to 141.1 feet away. Now I'm curious how he sees a water fountain that far away. His vision must be pretty good. So those are the 4 examples that we've done for angle of depression. So good luck.